Transmission media and antenna system. This topic is Yagi-Uda antennas by Cesarine Tampos. Yagi-Uda antennas introduction. The Yagi-Uda antennas is made up of a series of parallel thin-rolled elements in a line, usually have wavelength and supported by a perpendicular crossbar of what we call boom along their centers. There are a single driven element in the center consisting of two rods and connected to the one side of the transmission line, and variable number of parasitic elements, a single reflector on one side, and optionally a single reflector on the other side. Also known as a Yagi antenna is a directional antenna made up of two or more parallel resonant antenna elements arranged in an N-far array, designed to operate in very high, ultra-high frequency bands with an operating frequency range of 30 MHz to 3 GHz, coverage of 40 to 60 kilometers. Most common kind of terrestrial TV antennas to be found on the rooftops of houses. This figure below represents the structure of the Yagi-Uda antenna. Next is principle. Yagi-Uda antennas is an electromagnetic device that collects radio waves. An antenna tuned to particular frequency will resonate to a radio signal of the same frequency. History. The name is derived from two Japanese inventors, Hidetsugu Yagi and Shintaro Uda. Shintaro Uda of Tohoku Imperial University in Japan invented the antenna in 1926 with assistance from his colleague Hidetsugu Yagi. Yagi antennas were first widely used during World War II in radar system by the Japanese, Germans, British, and US. The concept of RF antenna design was first outlined in paper presented by Yagi in 1928. Since then, its popularity has grown rapidly to the point where a television antenna is now synonymous with an RF antenna with a central boom and numerous elements attached. And this is Hidetsugu Yagi and Shintaro Uda. Next is construction. A Yagi-Uda antenna is made of three main components that work together to form a structure. Basically, the arrangement is said to be an array of active and parasitic elements, and the dipole, generally a metallic rod, acts as an active element as external feeding is provided to it using the transmission lines, while a reflector and directors are parasitic elements of its structure. This is the three types of elements of Yagi-Uda antennas. The first one is the reflector. The reflector element is made up to be about 5% longer than the driven element. The Yagi-Uda antenna will generally only have one reflector. This is behind the main driven element, the side away from the direction of maximum sensitivity. Typically, a reflector with around 4 to 5 dB of gain in forward directions. Next is the driven. The driven element of Yagi is the point where the feed line is attached from the transmitter to the Yagi to perform the transfer of power, the transfer to the antenna. Element to which power is applied, it is normally a half-wave dipole or often folded dipole. And the last one is the director. Designed to be shorter than the element being driven, there could be none, or there could be one or more reflector in the Yagi antenna. The director or directors are positioned directly in front of the driven element in the director of greatest sensitivity. Each director adds about a 1 dB of forward gain. Through this level decreases as the number of the direction increases. Next is how it works Yagi-Uda antennas. First is driven element. The driven element of a Yagi is the point the feed line is attached from the transmitter to the Yagi, perform the transfer of power the transmitter to the antenna. The next one is the director or directors, used to provide the antenna with directional power and gain. Next is the boom. The spine of antenna used to hold the direction and reflectors and connect to the driven element. The last one is the reflector, used to reject the signal outside its range as well as amplifying what's inside. Think of a mirror reflecting light. This is the five elements of Yagi-Uda antenna. First, drawing of Yagi-Uda antenna, VHF television antenna from 1954, used for analog channels 2 to 4 and 64 to 72 MHz USA channels. It has 5 elements, 3 directors to left and 1 reflector to right, and driver element which is as a folded dipole. Double road to match the 300 ohms twin LED line feed line. The beam direction of graded sensitivity is to the left. The next is the radiation in the direction of the reflector. The antenna can be optimized to either reduce radiation by producing the maximum level of forward gain. The antenna exhibits a directional pattern consisting of a main lobe and a number of spurious side lobes. Reverse lobe is caused by a radiation in the direction of the reflector. And the direction of the main beam, Yagi antenna radiation pattern, the main spurious lobe is the reverse one caused by the radiation in the direction of the reflector. This is the application of Yagi-Uda antenna. This antenna widely used in the field of TV signal reception as it has excellent receiving ability. Even astronomical and defense-related applications make use of a Yagi-Uda antenna. Also, radio astronomy utilizes these antennas. And next is these are the advantages of the Yagi-Uda antennas. The first one is the directivity. The Yagi antenna is directional, enabling interference levels to be minimized for the receiving and transmitting. And the second one is the gain. The Yagi antenna has gain, allowing lower strain signal to be received. The next is straightforward construction. The Yagi antenna is mechanically relatively straightforward when compared to other designs. It can be constructed using straight rods with are simple to use and robust for most instances. And the last one is the polarization. The construction enables the antenna to be mounted easily on vertical and other poles with standard mechanical fixing. And And this is the disadvantages of Yagi-Uda antennas. The first is gain is limited to around 20 dB or so for a single antenna, otherwise it becomes too large and beamwidth narrows. For low frequency antennas, the physical size means the maximum number of elements, and hence the gain is much lower than 20 dB. These antennas are highly affected by atmospheric conditions. And next is noise is the major factor that disturbs the overall performance of the antenna. And the last of disadvantages of Yagi and Uda antennas is for high gain levels, the antenna becomes very low. And this is all of my topic of Yagi and Uda antennas. Thank you.